Hi and welcome. Today we're going to take a look at some of the inner workings of the zztat framework. So if you're completely new to zztat, I would suggest that you check out our other presentation, zztat, the Oracle Monitoring and Reaction Framework, which is a more higher level talk than this one here, where we're going to take a bit of a peek under the hood of the framework and talk about some of the internal processes and inner workings. I also have to apologize that we can't do this live as originally planned because we had some technical audio issues that we were not able to resolve. This unfortunately also means that you won't be able to ask me any questions live, but I will be leaving my email with you at the end of the presentation, and you're most welcome to just drop me a mail with any questions you may have, and I'll get back to you as soon as possible. So today's agenda, we're going to take a very brief look at just the framework itself and its different components that make up the framework. And we're then going to dive into the internal workings of a metric run. In other words, how the framework collects, analyzes, and ultimately reacts to your data. And we're also going to talk about some of the different tasks and the communications and roles that these tasks are performing. And finally, we're going to take a look at the scheduling aspect of a monitoring framework and the patching and security thereof. So zztat is the next generation monitoring and reaction framework. It collects data about your environment, it can analyze and evaluate that data, and it can automatically react. So in zztat, any data point of interest is called a metric to collect the data about your environment. We then have gauges which analyze the data that has been collected by the metrics. And finally, we have reactions which can then perform a corrective or also a non-intrusive action, such as a report production based on the results of those checks. So this is a high-level overview of the framework itself. As you can see, it is client-server based. So this means there is a zztat repository where we are keeping the history of all your metrics and where we can also do reporting and trend analysis stuff. And then there's the targets which we are monitoring, which are also running a copy of the framework, where the data is collected and then uploaded to the repository. Now, so zztat is not just a monitoring tool, it is a framework. So from the ground up, it has been designed to be fully customizable and extensible. So you can add your own custom metrics very easily. You can add custom gauges for those new metrics or for the existing metrics. And you can even define your own custom reactions. On top of that, usability has been given a high priority, and there's many different parameters that you can adjust to control how exactly the framework behaves. So the entire Oracle aspect of the framework is 100% SQL and PL SQL, so it is lightweight by design. So there's no big fat agents that you need to install and run on your servers. Everything happens inside the database and right where the data is. Management is fully centralized through the repository. We have a UI that runs on top of the repository, and there's also a full-featured API that allows you to perform any action the repository can do through API calls. So the framework is process-based, which means there are individual processes which perform set tasks and which are independent from each other. We have more than 40 metrics for Oracle out of the box with corresponding gauges. We have many reports which are built in and come with the framework. And the framework itself is also highly instrumented, and it can trace itself if there are any issues. Now the UI has been built on Oracle Apex. It is easy to use. It is self-explanatory largely. So you don't need to read any documentation just to figure out how to use this thing. Pretty much anything you need to know is always right there on the screen in the form of help texts that can guide you through the tasks that you want to do. The PL/SQL API is also completely scriptable and can easily be integrated with any kind of deployment framework such as Ansible, Puppet, Chef, or anything else. The UI is fully translatable at the moment, only available in English, but if there is demand, the UI has been written in a way that is easily translatable. Right, so if the framework collects data about your environment, it's going to do that in most cases through a metric. And what is a metric? It's basically just a SQL query. So in this example here, we see how the zztat framework collects the sessions which are running in an Oracle database. So the SQL query combined with certain attributes, with metadata, makes up the definition of a metric. The snapshot process is in charge of running the metric query and then storing the data in the framework for later analysis and also for archival. So when the snapshot runs, it will, in a nutshell, convert the SQL query that has been defined with the metric into an insert select statement, which it will then execute on the targets. So on the target databases, we have these bare-bone tables like we see in this example, the $CC session table, which are optimized for just high throughput inserts. So they don't do any data validations. They have basically no constraints on them, no indexes. They're really just bare bones to store one result set or many result sets, but in bulk. So this also means we want our metric queries to be fairly lean and efficient. So we want them to be fast, and we don't want them to use up a lot of resources. So now once snapshot has completed and has collected the metric data, it will then post an internal task, which ends up with the sync process. Now, in the case of the session metric, this is what we call an auto-sync metric. This stands in contrast to a standard and a regular metric, which basically just has all the individual components scheduled individually. So, for example, you could collect your data every 5 minutes, but you would only replicate it once an hour, and every 15 minutes you can run a check or another check every 20 minutes. For an auto-sync metric, it is all synchronized by the framework itself from start to finish. So basically all these tasks that we're looking at right now in this step-by-step guide is happening under the control of the sync process through the framework. So when the sync process detects that this snapshot has completed and it finds this post from the snapshot, it will then analyze the metric, and it will see that it has 3 gauges defined on it. And it will then schedule those gauges and create tasks for them. So in this particular example, the session metric has 3 gauges. We have the session idle TX, which checks for idle transactions. We have session pools, which can validate session pools, like in terms of if a group of connections suddenly goes missing because a middle tier server has gone down, or if we suddenly have a massive increase in the connections in the pool. And the third one is a gauge that checks for idle but blocking transactions. So if a session is blocking another session and that session is actually sitting there idly. So after sync has prepared these tasks, the gauges will be executed immediately, and the progress is then tracked by the sync process. If any of the gauges fail, again, the internal task will be updated and marked as failed, which is also tracked by the framework. So for example, we'll talk about state check later on, but one thing that he does is monitor failed gauges and metrics. Right, so when the gauge executes, the gauge is basically similar to a metric. It consists of a SQL query and certain metadata. Now, in the case of a gauge, the metadata that you want are the thresholds. So in zztat, we define two thresholds. One is a warning threshold and one is a critical thresholds. So if you look at the query, we have a fairly basic select statement which runs against this $CC session table to fetch the last call ET column among some other columns, and then injects the thresholds that we have defined. So for example, if a session has been idle for more than 300 seconds, we consider that a warning. And if it has been idle for more than 900 seconds, we consider it a critical situation. So the way that the gauge prepares the query is that it renders the conditions that we can define in our UI or using our API right into the query, and it then processes that query using DBMS SQL. Now this opens a whole lot of doors for us that we don't need to do any slow by slow or row by row processing with all these data points. We can simply process them in bulk using Oracle's very powerful SQL engine. So we can see the metric fetches data in bulk, and the gauge also processes data in bulk. So it's very efficient. Now this also means that the gauge queries we can add to zztat, if we choose to do so, should really only return interesting data. So data that we consider to be worthwhile of investigations or worthwhile of raising an alert. So we don't want the gauge to return good data. We don't want the gauge to return a table space that is 10% full. We want it to return the table spaces which are 90% full, so we can act on it. So if the gauge detects that a threshold has been violated or has been hit, it can then create new tasks which will trigger reactions. So in this particular example, we can see that our parent task for the snapshot process now has 4 child tasks already, and it has a new task for the reaction that the gauge has triggered. Again, sync will see that, and it will then trigger that reaction. So in this particular case, we have an idle transaction, an idle session. Most likely, this would be that we want to terminate the session. But this could also be that we send out an email address, we produce a report and send it out by email, or we post a message to Slack or Telegram, or we basically call any kind of procedure that we want after it has been defined as a reaction in the framework, of course. Once that is completed, this means that we have now collected the data, we have validated the data, and we have already triggered any reactions based on the data. We now archive the data or we replicate it to the repository. So the sync process will then initiate the replicate, which will upload the data to the repository and basically close the tasks, which now mark this metric run as completed on the target. So when replicate runs and has uploaded its data, it will then inform the repository that new data has arrived. This means for an autosync metric, like in the case of session, the sync process on the repository will also make note of that, and it can then create any gauge tasks for trend analysis or for historic analysis, and even can trigger reactions on the repository if we want, such as sending out a report by email, or any kind of reaction. And once that is done, the metric run is then completed in its entirety. Now, it's important to note that the data source doesn't need to be a metric. So this entire process can also take place with any kind of data source of your choosing. So this can be the data resulting from a third-party job or any kind of process, or it can even be a cron job. So for example, if you want to monitor file systems on your database servers, you can't really do that with just PL SQL. So what we need to do is basically run a little shell script that stores the data in a database table, and we can then pick it up with a so-called replicate-only metric. A replicate-only metric is very similar to a normal metric, but it doesn't include a snapshot. Now this allows the framework to basically process anything you can store in a database table, regardless of where it comes from. And lastly, with the addition of gateways to zztat, we are now also able to process non-Oracle metric collections. So while the data source is a different one, and it's not just a metric query that runs in an Oracle database, the framework still operates in the exact same way. So this means that after we have collected our data on a Postgres database or a MySQL database, or even some Python Boto3 call that reads metadata from Amazon's web services, as soon as the data arrives on the repository, the same mechanisms will then trigger, and the exact same code is used to analyze the data with the gauge and then trigger any reactions. Right, now let's take a quick look at some of the individual tasks in greater detail. So as we've seen, every action that the framework takes is always represented as a task. So the task always includes details about what exactly the work entails, so what we are doing, and its owner, so who triggered it. And of course, it also includes the fairly standard data, like what is the state? Is it new? Is it processing? Or is it completed? Has it failed? When was it started? How long did it take? And things like that are also tracked. So all the different processes which are working on these tasks, they always maintain their own tasks. So the snapshot process, for example, will maintain its own task. And in the background, we have the sync process, which kind of watches over everything. Right, so for the metrics, we have a total of 4 tasks, which handle the heavy lifting that we need to do with all the metric data. First and foremost, the snapshot. So snapshot only ever runs on target databases. Its primary job is to fill the staging tables with the output of the metric queries. And snapshot is always started by the Oracle scheduler. The snapshot process is also context aware. So what this means is that it knows how it was triggered. So it is able to determine whether the scheduler has just triggered it as part of a normal metric run, or if this metric run was triggered by, for example, a reaction. The zztat framework has certain reactions. For example, when it detects latch contentions, it can do additional data collection. So it can take some high-speed samples of your latching data, which is also done just through another metric. So the reactions have the ability to, based on the alert, then trigger additional metrics. And the snapshot process, being aware of that, enables us that we can update the metadata for that particular alert with the new data collected. So when the alert is going to arrive on the repository and ultimately in your inbox, you will be aware that there is additional data. There's one exception. If we are running replicate-only metrics, there won't be a snapshot, as we've illustrated before with the example of like third-party jobs or even a cron job. The snapshot process is technically optional. So snapshot goes hand in hand with replicate. So once snapshot has filled these staging tables, we want to make sure that the data in them is uploaded to the repository, and that's the role of the replicate process, or the primary role. What it does in addition to that is it also purges the data on the target databases. So one of the attributes, for example, that you can give or that you can set on a metric is that you always want to retain a number of snapshots on the target databases, and the replicate process also takes care of that for you. Now, replicate can be started by the Oracle scheduler if it's just a standalone replicate process, or it can also be started by sync, as we have seen with the autosync metric in the example of the session metric. Now, replicate is aware of the partition view implementation that zztat uses on the repository. So this means it will automatically upload the data into the correct table. And also, if you're using real partitioning, this will also work with replicate. We just enable you to run it on standard edition by providing partition views, but you don't need to use this. You can also just, if you have the licensing for it, run this on Enterprise Edition with actual partition tables. Then we have the gauge. The gauge can run on the target and on the repository. So if you run it on a target, ideally what you want to do is use the gauge for the checks that require a quick turnaround. So when a tablespace is about to run full, the gauge detects that, we add a new file to it. Or if a session is being blocked or many sessions are being blocked, we want the gauge to run right there and then on the target. On the repository, the idea is that the gauge works with historic data, so we can do trend analysis, we can do forecasts. So for example, in the example of table spaces again, when you're seeing that with the current growth, you're going to run out of space in 2 weeks, you can preemptively trigger an alert to let people know that they should consider adding space shortly. As we have also seen, there's a 1 to n relationship between the metric and the gauges, so you can have any number of gauges on each metric. Then the fourth musketeer is the React process. This guy is slightly different in that we want it to be able to be executed concurrently, so that we can fire the same reaction twice at the same time if we need to. Now, for metrics and gauges, this is not necessary, right? You're not going to run the metric, the session metric, for example, twice at the same time. That's not going to happen. But for React, we want to have this ability, which is why React has been configured as an event-based scheduler job. This doesn't need to worry you. I mean, you don't need to deal with this at all. The framework does this automatically, or to be more precise, the sync process submits the Oracle scheduler with the necessary events to trigger this job. So apart from just executing reactions, the React process is also capable of throttling reactions. This is important when we're using any kind of reactions which are a bit more intrusive. So, for example, if we're detecting a very high latch contention on your database, such as 70–80% of the sessions are blocked because of latching issues or because of concurrency issues, you may want to trigger a hang analyze automatically in such situations, but you don't want to run that every time that your session metric runs once a minute. You may want to do this only a maximum twice an hour, for example. So this can be configured accordingly, and then React will honor that accordingly. So that's it for the metric tasks. Those 4 are basically the guys which collect all the data and manage all the metric data. And then we have 2 processes which are kind of considered the core tasks of the framework, which make sure that everything runs smoothly and that the framework remains stable and operational. First, we have the state check. The state check runs both on the repository and on all the Oracle target databases every few seconds. Its primary role is to monitor other jobs. So you could compare it a little bit to Oracle's PMON process. And its other duty is to ensure that the Oracle scheduler job configuration matches what we have configured in zztat. So this means, for example, if we change the frequency of a job, let's say we want to sample our sessions not once a minute, but once every 2 minutes, you're making this change on the zztat UI in one central place or via the API, if you so choose. And once the target databases then refresh the metric data, the state check is going to be the one that synchronizes the appropriate job to that new schedule. Then we have sync. As is state check, sync is a very lightweight job. So it runs quickly, and it does basically everything it does in an asynchronous manner. So it mostly delegates. It doesn't really do any kind of data intensive work itself. By default, it runs every 3 seconds. And its main role is to coordinate the inter-process communication between the different zztat processes. What it also does when it runs on the repository is handle registration requests of new targets. So it will make sure that the basic sanity checks are done, like is this DB ID already registered or not? Do we have sufficient licenses to add a new target? Things like that. Then we have a couple supporting tasks, which are also needed to make sure that the framework runs stable into the future and doesn't really cause any negative impact on any target databases where it runs. So we have the part bot, which manages to partition views for us. So it automatically creates the new tables based on the daily, weekly, or monthly schedule that has been configured for that metric. And on top of that, it also manages the table statistics. So all the stats in the zztat schema are locked by default, and they're gathered by partbot when internal logic determines it to be needed. So this guy runs once an hour, just like Purge. And Purge, as we have seen as part of this presentation here, we do everything through jobs. So this means that on one side, we want to have diagnostics data or log data about these jobs available. But on the other side, of course, we also want to make sure that we don't fill your database with log data from the Oracle scheduler. So that's where Purge comes in. So it archives the scheduler log data and then purges it from the data dictionary for all the different zztat jobs. So this is basically also just another metric that we can see in action. So this scheduler data is then archived to the repository using a replicate-only metric. So the framework makes very heavy use of its own functionality internally. This is just another sample that I wanted to mention. Then we have ping. As its name implies, its main role is to send a heartbeat to the repository to let it know that the target database is alive and well. And since this is the one process where we are guaranteed to hear from on regular intervals, it is also the process which is listening for any requests to start the zztat on its target database. We'll talk a little bit more about the I in a minute. But it's a very basic process. Then we have the manager, which is it's playing a bit of a housekeeper role. It just doesn't sound as sexy as manager, so we decided to call it a manager. And what it primarily manages is the zztat internal data. So it is in charge of archiving internal log tables and also truncating the internal log tables when needed. And it also purchases data based on the configured retention. So basically, this job does the heavy lifting that we want to try and keep away from those high-frequency, lightweight jobs. Another thing it does for the built-in zztat metrics which contain lob data, such as, for example, the SQL queries or execution plans, which we store as XML in CLOBs in zztat, is that it compacts that data on the repository. So this enables us to eliminate a large chunk of the redundant data while still retaining a longer history of important metadata about the SQL statement. Then we have the mail queue and the chat queue. Now these guys may be running or not. It depends on which features and how you have your environment set up. So emails is one of the main notification methods that zztat uses, but you may not want your production databases to be sending out emails to the open internet. If your target database has not been configured to send out emails with zztat, the framework will detect that automatically. And whenever the target fires a reaction that wants to send an email, it will automatically redirect that request to the repository, where it's going to end up in the mail queue and it's going to be processed by the mail queue jobs. And the repository will then send the emails on behalf of the targets. And the very same thing happens with the chat messages. Natively, zztat supports Slack and Telegram APIs, but again, you may not want your target databases to communicate with those APIs directly, so we can defer it to the repository. This also happens fully automatic. So you don't need to reconfigure your reactions to do anything differently on those targets, which may or may not have internet access or access to emails. It's fully transparent and the framework knows this. So the repository also can send out messages to your Slack and Telegram channels on behalf of target databases. Then we have the zztat. The zztat is a new feature which allows you to get data from a live Oracle database without ever connecting to that database. This is enabled through the I process, which runs on the target when requested through either the UI or an API call. And the UI here that allows you to do this comes in two forms. So we have, of course, the desktop UI, but we also have a mobile app where you can start an eye session on a target database right from your phone. So this allows you to basically have a secure and controlled interface right into zztat framework core functionality. So you can produce a session report from your production database right on your phone without ever connecting to that database. If enabled, this can be a very, very powerful tool to have. And the eye is basically a process that controls this all. So it has very specific and predefined tasks that it can execute, which can or cannot then be relayed to those interfaces. So in other words, you can enable and disable pretty much any component of the eye that you want to expose as much or as little as you like to your users or to your DBAs, I should say. Right, then we have Autotask. Autotask is also a somewhat newer addition to the team of zztat processes, and it currently just runs on the repository, and it basically deals with tasks which are not metrics or related to metric data directly. What does this mean? For example, on the zztat UI, we use several different charts which we want to refresh at fairly short intervals. Now, if any of those charts require a bit of a more complex set of data, we want to refresh those asynchronously. And we want to do that as soon as the data becomes available. So autotasks are a mechanism that allows you to listen for specific tasks and trigger another task when that task arrives. So for instance, if you have a OS statistics metric that you collect on your target databases, you can say that whenever the OS stat is replicated to the repository and that replication completes, we then refresh our OS statistics chart, or the underlying data of that chart, to be more exact. So this is also triggered by the sync process, and Autotask is basically what does the heavy lifting. Finally, we have two somewhat specific tasks. I just want to touch on these briefly. Disable trace is something that only happens if you are using a reaction to automatically enable SQL trace in a session. So for example, if a job runs longer than expected, you can automatically trace it for a predefined interval, so for 5 or 10 minutes, for example. And disable trace then makes sure that the trace event is also reset in the corresponding session when it should be. The last guy is the gateway handler. So this guy runs if you are using any kind of gateways. It runs only on the repository. And it basically is responsible for submitting tasks to the gateways. So this guy will say, gateway number 1, please collect RDS instance details now. Gateway number 2, please fetch Postgres session statistics now. So that's what this guy is doing. Alrighty. I think we're almost 45 minutes in. All right, let me speed this up a little bit here. So as we've seen, the Oracle scheduler is basically what runs the core framework. So it's all based on the scheduler. When the framework was initially written, it was really the perfect match for zztat to be using the Oracle scheduler because of its flexibility, and just it is a very, very powerful job controller. So through that, we really have the flexibility to very easily and efficiently control what exactly we want to run. So we can literally run as little as we want or as much as we like. The scheduler makes that possible. So the scheduler ultimately controls the intervals for the metric collections and the gauges, and it also enables us to fire reactions in a controlled manner and concurrently. Now, all of this is centrally controlled, so the zztat UI is essentially an interface on top of the Oracle scheduler, if you want to break it down to that. So here in this example here, we're looking at the session metric, and we can see that it is collected once a minute, and we also see the SQL query there. And if we can change that to basically any frequency that we like, and the framework will then manage the scheduler accordingly to make sure that this is honored. Right. Now, if you have a framework and you're monitoring a whole bunch of target databases, of course the question arrives, well, what happens if I need to patch something? What happens if there's a bug in some process of zztat or something, a new feature comes out and you want to patch that? Do I have to go and patch all my 20 target databases? Nah, you don't. The framework can patch itself. So it comes with a full-featured patching infrastructure, which means that the only thing you need to do is provide it the patch. So you deploy the patch to the repository, and the framework takes care of it from there. So it will load the patch data, it will analyze the metadata of the patch, which is an XML file. It will then create tasks for the targets to download the patch data. And once the data has been downloaded, the task will be updated, and the repository will then know which databases have or have not successfully downloaded the patch. And it will then trigger the targets to apply or roll back the patch, also via its task management. Now, if any database fails to download the patch at this time, or is just down, or is under blackout, the framework has the capability on start of the framework to automatically validate its patch level against the repository. And if any missing patches are found, and if this feature has been enabled in the central configuration, it will automatically patch itself on startup. So this is really a full patching tool that we're talking about here. So we can have multiple steps as part of a patch. We can have dependencies between patches so that a patch will not apply unless a prerequisite patch has already been applied. And we also support offline and online patching, and fully automatic. So the framework will be shut down automatically if needed during the patching process. We support apply and rollback. Of course, we also need to be able to roll back the patches, but the framework is capable of automatically producing the rollback data that is needed, so we don't need to ship it with the patch, which makes it a lot easier for us to produce patches, because we don't need to make one patch for every possible older version that there may be. Instead, we simply can hand this task over to the framework to collect the current state of the packages and package bodies, types and type triggers as they are pre-patch, and store that in the repository, in the database. Right. Finally, I just want to touch on security, because of course this is software that runs on your databases, so security is an important aspect to be aware of. And zztat employs the principle of least privilege from the ground up. So it has no privileges it doesn't need. You won't find any kind of DBA privileges or even a DBA role or anything like that with zztat. There's a single any privilege that zztat user has, which is create any context. And that is simply because Oracle doesn't provide a create context privilege, because contexts are always stored in the data dictionary under sys, basically. And zztat makes fairly heavy use of application contexts, by the way. Right, so another thing that's very, very important is there is never, under any circumstances, any connections to your Oracle databases. It's simply not possible. The code to do that is not there. So all communication always goes from the target to the repository, but never the other way around. What this also enables us to do is, since we do have a centralized management, is that we can be sure that the configuration is always resynchronized with the repository. So in other words, you can't change it on the targets. So simple example, you have your database engineering team, and those are the guys that define what is monitored and how it is monitored and what the thresholds are and what kind of reactions are allowed or not allowed. And you then deploy that onto databases which may be administered by a different team. That team won't be able to change what you have configured or what your engineers have deployed. So the entire framework runs as normal unprivileged database users. So we have the target application user and the database link owner, which are existing on each target Oracle database. By default, they're called cc:user and cc:link, but you can change that. It's not hard-coded anywhere in the code or in any script or anything. It's fully dynamic. And these two users are also fully separated. So the database link owner is really the only account that owns the database link, and it has very, very limited objects and privileges. On the repository, there's the same scenario again. So we have the repository owner, cc$repo, and again, we have cc$link. We have a separate database link account. So the only communication that ever takes place is from cc$link on the target to cc$link on the repo. Now, if you're using gateways, anything that comes in from the gateways also comes in through a separate account, which is the cc$gateway user by default. And of course, you can also rename it to anything you choose. Now, you have seen that the framework can do privileged actions. So we can add data files, we can kill sessions. But how does that work? None of our users have alter system or alter database or any privileges like this. Instead, the approach we chose is that we deploy a package in sys, which basically everything the framework can do that requires elevated privileges is channeled through that one package. That package is optional, so you can install and run zztat without it. But of course, certain actions will then not be available, so the functionality will be limited. I think it's only fair if we ask somebody to install something under a highly privileged user that they know what exactly we install. So the syshelper package is always shipped in plain text, so you can really look at the code and see what it exactly can do. Yeah, and that's it for our zztat under the hood deep dive. I hope you learned something new today, and I hope I spiked your interest in the zztat framework a little bit more. As I've initially promised, any kind of questions, please send me an email, stefan@zztat.net, or for any kind of sales-related inquiries, or if you want to get a trial we do offer free trials, by the way. Shoot over an email to sales@clouddb.solutions. All right, thank you.